Alright, number 26. The height, y, in feet of a basketball, t seconds after it is thrown, can be modeled by the function blah. Find the maximum height of the basketball. So there's one statement. How long is the basketball in the air? There's your other statement. Okay. So I got a basketball. Again, lying on the ground. Nobody caught it. The only really thing I know about this is it was thrown 2 feet off the ground. That's a 2. Okay. It says find the maximum height of the basketball. Well, the maximum height is right here at the vertex. So I need to find the vertex. Then it says how long is the basketball in the air? Well, it's in the air until it gets to right there. That's where it hits the ground, which is an x-intercept. All right. Now I know there's an x-intercept over here, but remember this is the height. Y is the height, and this is time. That would be a negative time over here. We don't delve. This is not Back to the Future, so we don't care about negative time. So again, what we're looking for is we need to find the vertex to find the maximum height, and we need to find the x-intercept on this side in order to find where it crosses the x-axis. So here we go. Oh, sorry. Y equals negative 16t squared plus 32t plus 2. Alright, I can't divide negative 16 out of all of it, so I'm just going to divide it out of those two. So y equals negative 16t squared. 32 divided by negative 16 is negative 2t plus 2. And now this is the b value I'm going to use, not the 32. So I'll go over here. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1. So on the left side, I'm going to add 1 times negative 16. If you don't remember y, I'll show you why in a second. And then I'm going to do t squared minus 2t plus 1 plus 2. Okay. And again, I added this 1 times negative 16 because this 1 is being multiplied by negative 16. Okay, so I added a 1 times negative 16 over here, so I'm going to add a 1 times negative 16 over there. Alright, that is y. Alright, so let's start cleaning it up. This is y minus 16 equals negative 16. That's going to be what? T plus, no, it's going to be t minus 1 times t minus 1 plus 2. If I move that negative 16 over to add it, I get negative 16 t minus 1 squared plus 18. Okay. So that's my standard form. So I know my vertex is at negative 118, therefore my maximum is at 18. The maximum height equals 18 feet. Is it in feet? Yeah, feet. Wouldn't be 18 yards. It's a pretty high basketball, but I guess you could throw 18 yards high. How long is the basketball in the air? Well, that's an x-intercept, remember? Whew, my bad. That's an x-intercept, so that's where y is 0. So let's plug 0 in for y. If y is 0, negative 16 t minus 1 squared plus 18. Just start solving. If I move the 18 over, it becomes negative 18 equals negative 16 t minus 1 squared. I can divide by negative 16, so that becomes 18 over 16. And I can reduce that, but I'm going to leave it alone because I can square root the 16. Just leave it there. We'll reduce it in a second. And the reason, again, if I square root both sides, I can't square root the 18. I got to go reduce that, but I can square root the 16. The 16 becomes a 4. All right. And then let's go clean this left side up. We can go clean this left side up a little bit further. So the square root of 18 is what? The square root of 9 times 2. 9 times 2, that's 3 on the square root of 2. So let's go back. I'm going to do two things at once here. I'm going to move the 1 over so it becomes a positive 1, plus or minus the square, not square root, 3 times the square root of 2 divided by 4. Yeah. Which I don't know what. Yeah, that's good enough. So here we go. Again, last but not least, what do we want here? Where does it land, or how long is it in the air? We do not want the negative answer. We want the positive answer. So x plus 3 squared over 4, that's going to be positive. At 1 minus that is going to be your negative answer. So my final answer is 1 plus 3 root 2 over 4. That is my answer. It's not both of them, it's just one of them.